Hello world, it's Angelot, and in this Dots on the Map video, I want to focus on getting real data into a map. So I'm going to start with the Counted project from The Guardian. You can download the data from their website. And this is a database of people killed by the police in the United States. They've already got a map with squares on it, almost dots. It's Mapbox.gl, as you can see. So we should be able to make something just like this from their data. I'm going to take you through it. So I'm going to load the data into Block Builder first. So we're going to choose it from the file system. You check it out, we'll see that there's name, age, gender, race, some time, but there's only street address and city and state. There's no latitude, longitude. So this is our first real world problem with a real world data set that we want to solve. And actually, this video is going to mostly focus on getting latitude and longitude coordinates for an address or a data set of only addresses. And for that, we're going to use Maps and Search. And you can see here that they have an API. You can send it some text, like an address that we have. And we're going to go pull one of the addresses from our data and test this out. So if we replace the text with the address, we also need to get an API key. And in this video, I'm going to use one that I already set up. You'll want to set up your own because, by the time you're watching this, that API key will probably be expired or overloaded. So anyway, the results get back a query, which is the address that we queried for, and this list of features, which is an array of JavaScript objects, and each one has some properties which show us the address that is matching that feature. The locality is what we generally consider the city, and the coordinates. And the coordinates is what we really want so we can draw our map. So now what we need to do though is request the search for every data point that we have. So I'm going to do this in Block Builder. We're going to build a sort of interactive geolocation tool actually using just some simple D3 and visualize the result of the API call, this JSON here, in Block Builder. So let's get started. Let's load up the data, the CSV that we uploaded into D3. And the first thing I always do is console.log the data, make sure I see it. We got about 1,000 entries here. We see the street address, state, city. And so now we want to loop through the data and create the search term from the properties, right? So the street address plus the city plus the state that we can use in the API call from Mapsen. But what I like to do even before I get into the API is make sure what I'm working with is what I expect. So I create a pre element, so we can just stringify essentially all the search terms from all the data. See all the addresses listed out here. If you make it 100% height and give it the Y, you can scroll through the list. And I always find this a convenient, super quick way to kind of see a bunch of my data laid out before I start really messing with it, because this shows me that I can kind of expect the addresses to work for the geolocation search. Another thing I like to do is just separate out a rendering function. This kind of forces me to use the enter, update, exit pattern, especially for things where I know it's going to change, because I'm going to loop through my search queries and update all the rows as I get the results. So here I am changing the pre to a div so I can output all the rows in the div, starting right away with the D3 update pattern on divs instead of SVG elements. So here I have a bunch of divs classed row, so I can change their font. I can change the font size, maybe a little bigger, and I'll organize them sort of in a fake table in a way, just float left, clear left. Super quick, super easy to work with, space things out a little bit with the margin, and you got yourself a table going. So another thing I always do really quick is set up a click handler with D3 on my selections. That way I can sort of visually debug easier, just click on something if it's not what I expect it to be. And that just can come in handy later. So now, let's set up what we want our geolocation flow to look like. We'll basically use d3.json and call some URL, which will have to compose from the search address as well as the API key and and the base URL. But I'm going to store the returned GeoJSON on my data element, which will come in handy when I re-render all my data rows. And I'm also going to set a timeout, a staggered timeout, so I don't run into the rate limiting issues that MapSend has. Most APIs like this will have some kind of rate limiting on them anyway. And besides just the number of requests that's limited, it's also how often you can make requests. So you can have 6 every second. So here with 200 milliseconds, I have 5 every second. So I'm just under the radar there. So see how I'm storing the geo on the element and then updating the render. Now I'm about to set up the URL, but first I'm going to set up a test slice of the data. So we're only making 10 requests. I'd rather not use up 1,000 requests every time I call update the code and we call the API on each address. So here we're going to add in the search term, and this should already be giving us back results. Open the console. There we see our geo objects. So our d.geo is one of these with their features and the geocoding object. So the features, or the geocoding, will have our query, but the features is the list of items with the address, as well as the region is the state code that we're using. The name is kind of the street address that we submitted. And each feature will also have the coordinates, of course. So let's get into, we added delay sometime, or while I'm developing, I added a delay so it wouldn't immediately start requesting a bunch of things every time I typed, but it's not really a big deal for the purpose of this video. More something that you might do if you're developing a block builder interactively like this. So now we want to see each of the 10 features we get back as their own rows in this table that we've got going on over here. So I'm going to use the D3 enter update exit pattern again, this time with nested selections. So we're going to set the data for this selection to be the list of features. And that will let us, well, first we have to actually filter out anything that doesn't have the .geo element on it, because there's several, we call render every time we get a new response with a new geo, but that means there's a lot of things that won't have a geo on them yet. So now we can enter and add a new div.geo for every one of the features using this geo selection. And we're going to give them a class. We'll set the text to a function of the, well, first we should see what we should return as the text to get a sense for, from the properties, we want to see the label. That will show us the address that was found for each feature. And we'll see here that, okay, we got the address. Oh wait, we didn't. So we have the properties. So I have a bug here. Oh yeah, I forgot to return it. That's why it wasn't showing anything. So now we see all the addresses on the left there, each one, and we can see that there's addresses that don't match our original query. We just get things that are close by. So now I'm going to try to position the geo rows, make them floated. We want to clear the first one so that we can see a block of the return geo addresses below our original address, and this will be handy for kind of showing, let's see, I need to inspect, oh right. So we didn't append our original address as a floated div, it's just some text. So we need to actually change the way we're creating our divs and add a new div, an original address div, using the enter selection there. And then we can float that, which still isn't working because I'm not properly setting the text on the entered. There we go. So now we have our original address. We can kind of highlight them with a border, do some padding, and then space out the geo addresses, give them a hover effect when we hover over them. well, we can get to that. So we just give a light border to our features there. And what we're going to want to be able to do actually is make this interactive, because if we get an address that doesn't match the one we searched for, so for this case, actually all the geolocation results we get are for the wrong state, which is a problem. But this is where visualizing the results is super handy, because we could actually visually inspect this stuff and see it without, in a scripting environment like Node, we might not notice that in our console logging in the terminal. So here we can just filter out anything that's not the same state. So we actually see that that one didn't have any geolocated addresses. There's some that just have only one or a few. And this is again where we want to be able to get into manual curation by the end of this. We want to be able to automate as much as we can, but then see the result, or export the result actually, of the geolocations that we've manually verified to trust, and then we can map that. So let's get towards that interactive aspect. The first thing we'll want to do when we're getting into interaction is be able to log out the data that we're going to be manipulating. So we want to be able to see when we click on an individual feature, we want to see the data that we're clicking on, just to confirm that. So we'll log out the individual feature here. But actually when we're clicking, we're getting the parent data from the parent div, because the parent div had a click handler on it already. So instead we just move that handler to the original div, and now when we click on a child, we can get its individual feature data. But we want to be able to add a selected property to the parent data. So we'll do that by selecting the parent node, getting its datum, and now when we click, we see that we've added the selected property to the parent element when we log out and click, when we click on a child element. And so this is how for each original address we can choose the feature that we want to represent our geolocation in our final output. So I want to be able to see all the selected ones, but we should by default select the first feature of every element, so that way we don't have to click on 1,000 rows if for the most part the first element is works. And sometimes since we're rendering based on the geos, we could set a selected attribute, with this geo selection with the individual feature data. But instead, let's set the background color based on the parent. If the parent's selected attribute is the current geo's featured datum. So we're just showing gray or white. Gray is a little dark here. Let's make it a lighter gray. And we see the first element's all selected. So now when we click on a child, we need to re-render with the updated data. So we've got a little bug here where I'm rendering with the data, and it seems like when I click, it didn't update the selected element for some reason. So I'm clicking on different addresses. I get the proper child data, but it's just not updating this deselected. So instead of rendering it directly there, I want it to okay, there it worked when I didn't re-render. So that's a good sign. So instead of rendering there, we can copy paste sort of this same update. Actually, we'll make a function and just make this, reevaluate the background color when we update the selected here, instead of trying to re-render everything. And that's something to look into for the future, why that didn't work. But for now, we can select our arbitrary addresses and save them on the original data. Save this real quick as a dots on the map project. I probably shouldn't have waited this long to save, since I got things working on the screen earlier. I always like to save frequently. It doesn't cost anything. So let's add a place, let's squeeze the original output we were visualizing and have something to output our CSV. One thing I like doing is actually using a text area to hold the results of some stringified data or some, you can do the inverse of a CSV parsing. You can turn an object into a CSV or an array into a CSV text. And if we output it into the text area, we can actually copy paste it out into a file or into another block for rendering. So we're just going to hook up a quick save button, just adding the cursor pointer to make it more obvious that we could do different. I'm not sure why this color didn't show up, but the hovering isn't working quite as I expect. So, it's not that important. Shouldn't get too held up on it, but space out things a little bit. Anyway, getting hung up on the styles, so let's just position our button. I like to use position absolute and just throw things on the screen while I'm not worried about creating some kind of super app. This is just the bare minimum to make a tool to increase my own workflow speed. So we have our save button, so now we need the functionality wired up. When we click on save, just using D3 to handle the events, and relatively simple. So when we click save, we're going to want to create a CSV string, so we can use D3 CSV format, pass in the rows. Rows is an array that will build out of our original data. So when I save now, rows doesn't exist. So we're just going to loop over all the test elements, and we're going to decide whether or not to push a row on. So if something didn't get selected geocoding, then we don't want to include it in our final output. And then we're going to use a trick here to copy each element. It works on simple JavaScript elements, this JSON parse, JSON stringify, but that way we can delete parts of our copied elements, and then, because we don't really want to put geo or selected in our CSV as a column, so we're removing those, but we do want to put our coordinates as a column. So here we also keep track of a list of unprocessed elements. And this allows us to, let the user know how many things weren't saved. So here we see the CSV output, but we don't have our lat longs yet. So we can quickly add a lat and a long property from the selected object. So we're going to get it off the geometry's coordinates and, make sure that works. So we'll change something here or there, click on a few items, and change them, and then save. Oh, but I think we have to check for selected first. And oh no, we deleted selected maybe. Let's see. Now I still have an error. So yeah, we need to check that selected exists, because not everything is selected, right? So we'll just put that in the case that selected actually exists, change our one thing, and now we have we should have a latitude and longitude. Yeah, there we go. So we can copy that. We can go to our earlier dots on the map, and we can actually just paste this in here in the data. We will have to change the accessor that we use, because we had lon in here before. We'll change it to LNG, which is how Mapbox tends to denote it. So I'm just going to stick with that. And sometimes to find the center of, a place, I just go to Google Maps and grab the latitude, longitude from the URL right there. And I don't know, it's the quickest way I can think of to quickly get some locations. So we're just going to center our map instead of on London, which is what that example was on, somewhere in the middle of the country. Zoom out, and there we have some dots on the map. I'm just going to adjust the center a bit using Google Maps as a reference, and then interactively changing the lat long for center. I like just changing things in Block Builder like this, because you can immediately see the results. And now I'm going to save this, because we got some dots on the map. Whenever I have progress, I try to fork or save. I'm going to update this one so that it's more appropriately titled. And then let's do it for the full data set. So all 1,000. This is going to kick off the geocoding for everything. As we scroll down, we'll see more and more addresses getting geocoded. Since it's delayed by 200 milliseconds for each request, it will take a little time for this to finish. If we scroll down far enough, we should be able to see the fact that not everything has finished rendering yet. So we'll do that in a second here. see all these down here. It's moving pretty fast though. And yeah, I mean, if we did our math correctly, this shouldn't get rate limited. We can, check in the console what's going on. A lot of action. It's going pretty fast. Looks a little faster than 200 milliseconds to me, but I don't know why it wouldn't be what we say. So, we can get ready for this map. We'll adjust it a little more while it's going, and get it centered nice for the way things will look in blocks. Just make these nice round numbers. No reason not to. Save that. So here we see some errors, so that indicates there's probably some rate limiting going on. So I'm just going to go ahead and save out and see that I processed 740 out of the 1,000, and we paste the data in. There's 700 dots on the map. So yeah, that's geocoding interactively with our own UI. We can zoom in, zoom out, see our dots move around on the map. There's several things we could do to this UI to make it better. You could output a list of all the unprocessed ones so that you could go manually fix them. We could show progress at the top, right? We know what's being visualized. And that's really all we have for now. Don't forget to subscribe on YouTube. Leave a comment if you have any ideas or requests for more videos on dots on a map. Yeah, enjoy. Get geocoding.